Hi, everybody. This is Robert Hodges, and I'm one of your presenters today at our webinar, ClickHouse Defense Against the Dark Arts, Introduction to Security and Privacy. Before we get going on this webinar, I'd like to just give you a little bit of information that will help you enjoy the webinar more and also um, be able to ask us questions. So first and foremost, this webinar is being recorded. Because you signed up, we will automatically send you a link to both the slides as well as the webinar recording a short time afterwards. So you don't have to take frantic notes. You'll get the slides. Next thing, we have a Q&A box. So as the webinar is proceeding, if you have questions at any time about what we're presenting, feel free to pop up that Q&A box and ask the question. Some of them, if they're relevant to the slide we're on, we'll talk to them right then and there. We also have time at the end of the webinar to take questions, and we'll try and answer all of them. Final thing, we'll run a very short poll at the end of this webinar, and that's just ask you 3 simple questions. It's very basic information, helps us make these webinars better in future. Okay, with that, let's dive in. Excuse me. So once again, my name is Robert Hodges. I'm CEO of Altinity, and my background is I'm a database guy. I've been doing it for about 37 years, actually. ClickHouse is the 20th database I've worked on in one form or another. And I've taken a couple of side trips into virtualization as well as security, which is actually one of my favorite topics in software engineering. I'm joined today by Alexander Zaitsev, my friend and colleague. He is our CTO, one of the founders of Altinity, and he has decades of experience on petabyte scale analytic systems, including ClickHouse, but also extending to other technologies like Vertica. And here's just a little bit about Altinity. So we are the #1 enterprise ClickHouse provider. This is a broad ecosystem. Many people offer services related to ClickHouse, but our focus is on making enterprises successful in building analytic applications that add value to their businesses. We are a major committer as well as a community sponsor for ClickHouse, particularly in the United States and European markets. Normally, I stop here at the introductions and get straight to the technical detail because I know you all are geeks just the way we are. But I'd like to make a slight deviation from that and just talk a little bit about why Altinity is somebody that has something to say about security and privacy. And the main reason is we work on it constantly. It's probably the biggest single focus of our engineering effort. We also do work with things like storage, uh, new forms of compression, Kafka, other things, but security is definitely a really big focus. And I'd just like to give you a sense of some of the things that we've helped to work on in or helped to complete in ClickHouse. So among the completed work, we've done things like log query masking. We'll talk about that and how you can make particular types of information disappear out of the log. We implemented Aes encryption functions. We also implemented LDAP, and there's a couple different forms. We'll talk about that. We also did most of the testing in fact, almost all of the testing for role-based access control, and that's an important part of what we do. ClickHouse is a community. There are hundreds of people who submit PRs on security features, even those that we don't implement ourselves. One of the things that we take responsibility for is to create the tests for them. So role-based access control is a very broad interface, and we wrote a test suite which is using a tool called test flows that has literally thousands of checks on, I think it's something like 7,000 checks on the different features of role-based access control. These are all things that where we've finished the implementation and testing. We have in-flight work around Kerberos, boring SSL, lightweight update delete, an audit trail. We'll talk about all of these later in the presentation. And then we have a roadmap that includes a bunch of stuff that we're working on with customers to define requirements, prepare designs, and to move forward. And these are everything from trusted builds to things like transparent data encryption with server-side key management. So that's us. We really like security a lot. And so for that reason, this is going to be a really fun webinar for us because we get to talk about stuff that we enjoy doing. I'd like to just give a very quick introduction to ClickHouse because I know that not everybody on this call is a ClickHouse expert. So we will go ahead and, uh, oops, 1 second here, just something popped up on the screen that I didn't expect. Sorry about that. We'll go ahead and introduce ClickHouse, kind of level set so that you understand what ClickHouse does. So if you haven't used ClickHouse before, it's an open source SQL data warehouse. You can think of it in a way as being the child of MySQL and Vertica. So imagine that they got married and they had a kid, and that child would look like each of the parents. So there's no relation in the code, but from the MySQL side, you have things like a single binary, which just runs practically anywhere. Of course, you understand SQL, you're open source. Now, ClickHouse, as you probably know, is Apache 2.0. That's a much more flexible license than 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 MySQL, and in fact, a nice contrast to some of our competitors. From the Vertica side, Vertica is a very well-known data warehouse. We get things like the ability to, or the fact that we store the data in columns, so arrays of highly compressed data, parallel and vectorized uh, execution. So not just vectorization refers to the ability to break things up into pieces and use SIMD instructions on individual cores. Plus, we can also run in parallel, both across many CPU cores on a single host, as well as across many CPUs. The scaling is enormous. There are many ClickHouse clusters that run into hundreds of nodes. And just beyond that, because of all this, because of the implementation, both things like storage, as well as the ability to parallelize, as well as just very, very tightly honed algorithms, ClickHouse is incredibly fast. And in fact, this tends to be the thing that people notice about it when they first use it. Unfortunately, for modern applications, it's not enough to be just fast. And that's really where this talk comes from. So we'd like to explore two main issues here. Security, which is protecting ClickHouse and the data within it from attacks from within and from without, as well as privacy. And privacy means building applications that comply with standards for protecting user data. So these are closely related. The security part, which we'll spend the lion's share of this talk on, is really specifically related to ClickHouse, and it's mostly an implementation thing where, depending on how your administrators set up ClickHouse, you can achieve higher or lower levels of security. Privacy is an interesting topic because in order to achieve privacy, it goes a little bit beyond just ClickHouse itself, because you have to begin to think about how your application is designed and how it treats data that's loaded into ClickHouse. We'll go into both of these topics in full detail. So let's go ahead and start with the topic of securing ClickHouse servers. So I'm going to begin with something pretty simple. Well, first of all, a list of just what we're going to cover. We'll talk about setting up users, authorizing access, uh, encryption, and we'll look at a couple different ways. We'll look at encrypting your connections, and we will also talk about encrypting data at rest. We'll talk about preventing data leakage, and then just some pointers on securing your ClickHouse host. By the way, there's a question, which data protection standards are you referring to? GDPR, yes, that's the main one, but there are now others like the California data protection laws, which were recently passed. So this is just something that's now becoming increasingly standard in applications. Let's go ahead and start with users. So if you've been using ClickHouse for a while, you probably know what these files are. ClickHouse started out by just using an XML file to define all the users, and then in addition, things that are called profiles, which consist of configuration settings and resource limits, and quotas, which are actually quotas for usage. And so the way that you do this is you go ahead and you just put the data into these XML files. ClickHouse is very good at recognizing when the files have been changed, so you don't have to restart the server if you want to add a user. For example, you would see something like the following. If we wanted to define a root user, and there's a typo here, you'll see user. So you'll put this in a little file in the users.d directory. have it read-only for ClickHouse, and then you'll add things like, first of all, you put a tag in that says root, and that's the name of the user. The typo is that it's RO user before, because I took this from a previous example. Then you have the password, which is a SHA-256 hashed uh, value, in this case for the word secret. You'll have some things here which say which networks we can log in from, which profile you use, which quota you use, and then finally a very important thing in modern ClickHouse versions, access management. So that says whether we can use the role-based access control commands, create users, assign them privileges, and create new roles, things like that. So this is a typical user definition. So you'll put this into a file, you'll pop it into Etsy, ClickHouse server, users.d, and all of a sudden you've got this user that you can now log in as and use it. So there are a few tips for this that apply to users in general. These are just some things that we've seen that are confusing, and I'll just cover them here. The first thing is when you're generating these SHA-256 passwords, it is really common to forget that if you echo a word like secret to SHA-256, or SHA-256 sum, it includes a carriage return on that. Ask me how I know. But this is a mistake that people commonly make. So you say echo -n. This is just a trick for generating this correctly. If you forget and don't have these slides, it's also mentioned inside the ClickHouse configuration files. Another feature that can be kind of confusing but is very helpful is network masks. So these are masks that say that the user can only come from certain hosts. And what ClickHouse will do is it'll look at the IP headers, figure out where the user is from. And this is very flexible. So there's a bunch of ways that you can limit things. So for example, the first example would only allow a user from localhost. The next example would allow it from a specific subnet. That's a CIDR address with the subnet on it. You could allow it from a specific host, and then very flexibly you have what's called a host regular expression, where you can actually define a set of host names that match. And what ClickHouse will do is it will actually go out and figure out what the IP addresses are of these and fill this in for itself. So this is a super useful feature, and definitely something that you want to that you can use, for example, in defining this root password or excuse me, root account. It can only then log in on the local host, which is good because it's a pretty powerful account. So these are just things that we've run into and answered in support cases. The biggest question, though, is when you're manipulating these files, the thought that occurs to most people is, wouldn't it just be way better if you could do this in SQL? And the good news is that one of the really great improvements in SQL, in ClickHouse over the course of the year 2020, was that we added full role-based access control, as well as the ability to create users, quotas, and profiles, and all the other types of things which are required for user management. And this is a simple example where we're creating a read-only user. And so we do a create user, we go ahead and revoke all privileges on it. We then create a role, which has the ability to select off the default database. That's the standard database that's always present on all ClickHouse servers. And then we grant that role to this user. So the syntax that's used here is, a lot of this is standard syntax, but in the ClickHouse case, there are features of it which are reminiscent of MySQL. So if you have used MySQL security and are familiar with their Rbac implementation, you're going to be pretty much at home here. So this is a super useful feature. And beyond that, we'll talk a little bit more about applications of role-based access control, but this is a really, really great model and includes very granular protection. So the number of things that you can grant privileges on is huge. So for example, for tables, you have all the usual, basically any command that affects a table, be it create, insert, alter, delete, select, you name it, you can grant specific privileges or revoke them, as the case may be, so that you can control whether individual users can run these commands. For databases, you can do create, drop, and show. For access management, all of the major entities like users or roles or policies, row policies, all of these things can now be created and managed through SQL. And then finally, all of the system commands similarly can be protected using role-based access control. So we've tested this extensively. As I mentioned, this was an effort that ran for actually I think has run for close to 8 months. And there are relatively few holes in this model that we've found. It's quite stable, and particularly if you're using an up-to-date ClickHouse release, it's a really great feature. Now, one kind of interesting question is what happens when you create a user? Because one of the criticisms that we hear, when we talk to people about the old XML-based model is, hey, you created a user and there's their password just lying around on the file system. What happens actually when you create a user using these new SQL commands? Well, the answer is there's still a password and it's still on the file system. So let's just look at what happens. So here's a simple example of where we're creating that read-only user. And what's now going to happen is that's going to get submitted to the ClickHouse server. And what it's going to do is go ahead and create a file out on varlib ClickHouse access. That's the default location for this information. So there's a new set of metadata that's now being created on the server that helps manage users. So, and what you see is, if you're familiar with how ClickHouse internally manages tables, this will look pretty familiar. So we say attach user, and basically this will get read when the ClickHouse server starts up so that it will know who that user is. So what that means is that you still have this information on the file system. Moreover, if you want to change the properties of a user across a cluster like the password, you're going to have to go to each of the servers and actually execute this command. One thing I should mention is the create user command. I don't show it in this example, but they do support the on cluster keyword so that you can create a user and just blast it out across a cluster. But the point is you still have to have this metadata file present on each of the servers for that ClickHouse, for that user to be recognized. So that does bring up the question of, is there a way of centralizing users so that you don't have to do this? And it turns out that there is. One of the things that we have spent quite a bit of time working on over the last year or so is LDAP. So this is the first example of what we call pluggable authentication. In other words, their interfaces now inside ClickHouse that allow us to build different implementations of authentication. And this command here shows you what you can do since ClickHouse version 20.8. You can now create a user, and then you can just say identified with LDAP server and then the name of that server. So, and we'll show you how that's how ClickHouse figures out what LDAP local means. But this is basically now a new way to create users. And if you do this, what is going to happen is when this LDAP user tries to log in, ClickHouse is actually going to go and check inside an LDAP server to find out whether the user has given the right password. One thing I should note is there is a change coming that the keyword will change to LDAP from LDAP server. That's something that's going to come when Kerberos support is fully implemented. So here's the flow. We define that user, and so we log in with ClickHouse client, which is everybody's favorite client to log into ClickHouse. That goes to the server. The ClickHouse server knows that it needs to use LDAP local to look up this user, and there's a new extension to the configuration file where you just give the connection information for the LDAP servers. So you'll have one, you give the host name, you'll give the port, you'll give security information, for example, if you're using TLS encryption, and what it'll do is it'll march out to the LDAP server, go look up this user, and then find out what their password is. If it matches, they log in. If it doesn't, they don't. The nice thing about this is it means that you can go ahead and, of course, change the password in one place, and then it takes effect for all users. Moreover, that password is no longer on the file system. So this is a big improvement, and one that we we plan on using ourselves in the services that we run, and we expect will be pretty popular in the community as well. Okay, so that's user management and role-based access control. So the ability to authorize things. What I'd like to do is shift gears a little bit and begin to talk about encryption. And we're going to start with considering in-flight connections. So how people connect to ClickHouse over the network and how those connections are protected. One of the things that's really interesting about ClickHouse is that it has a huge diversity of types of connections that it can accept. This little picture here shows all of the ClickHouse uh, types of client ports that are supported, and they go from the sort of obvious ones like the HTTP and the native TCP compliant client. um, so they have different ports, and then there's a bunch of relatively new ones, everything from MySQL client protocol all the way down to Prometheus metrics adapters. So these are additional client types. Finally, there's a port that ClickHouse server maintains to help with replication. So if you're running a ClickHouse cluster, the way that it works to replicate between tables that use the replicated merge tree is Zookeeper is used to store centralized information about what are the parts, in other words, the pieces of the table that need to be replicated. And this port, which is called the inner server port and defaults to 9009 when it's unencrypted, is where the servers go to fetch these parts. So what we want to do is we think about this as the attack surfaces. What we now want to do is go ahead and anything that's marked in red, we want to make sure that's turned off because those are the unencrypted ports. So for example, for the HTTP client, it defaults to 8123 when it's unencrypted. And when it's a TLS encrypted or HTTPS connection, it's 8443. So what we want to do is turn off the red ones and then light up the green ones, and so then we will only have encrypted communications coming into the server. The other thing we'll do is we'll go ahead and just any other port that we're not using, we'll just go ahead and close down. So let's go ahead and step through how we do that. So here's the process. As I just said, we'll turn off the unused ports, we'll enable TLS encryption, and then for clusters, in addition to switching to TLS on inter server communications, we're going to define a user for remote calls. So let's go ahead and look at those steps. So the first thing is turning off unused ports. So anything that, for example, if you're on a local server, there's no particular reason to have inter-server HTTP port open, and certainly no reason to have MySQL port unless you're using it. So we go ahead and just turn those off. And all you have to do is comment these out. In fact, the MySQL port should be commented out by default, and then you'll just restart the server. ClickHouse does not pick up network changes automatically, so you're always going to need a server restart to do this. The next thing we want to do is enable TLS client connections. So this includes turning off the unencrypted ports and enabling the TLS encrypted ports, so the HTTP port and the TCP port secure. So that's the easy part. The hard part is that in order to do this, you're going to need to supply an X509 certificate and a matching key. This is standard for, to make, so that the key exchange can work. So we're going to have to create this certificate, and we'll talk about how to do that in a minute. Another thing you have to do is supply Diffie-Hellman parameters. These are optional, but fairly easy to create. You can read the instructions in the config.xml. So we're going to need to fill this information in. So the big topic is how to get your server certificates. And for ClickHouse, there's basically three options that we see people using. The first is to get your certificate from a public certificate authority like Let's Encrypt. So it's pretty easy, and this is great if you're doing external services. So for example, we run Altinity.cloud. We will use a public certificate authority for our certificates. And the important thing is that this is good because it works if you have large numbers of clients or clients that you don't control, because getting any, because what will happen is those clients will accept this certificate automatically without you having to do any special configuration. So for public facing things, or for services that have a large audience, this tends to be a really good solution. Another solution that's very common for internal systems is to have your own internal certificate authority. And what that means is you generate your own root certificate and you use that to sign the certificates that you then hand out to the ClickHouse uh, uh, servers. This is good because uh, it allows you to, if you have in-house systems, it will allow you to support them very easily, and you don't have to bother with calling out to an external certificate authority. The other thing is that you can do it very fast. There are some downsides to this, which we'll talk about in a minute. And then the final thing is self-signed certificates. The only reason I would do these is for testing, just to confirm that I can put a certificate in and it will be consumed, and ClickHouse will actually connect. But they are worse than useless for production data, because basically any client that connects to them has to turn off verification of the certificate, which effectively means it's throwing away the basic protections that you get through encryption. So you use this for testing, but in the ClickHouse case, you never want to use this for real data. For more information on the procedures on this, we have a blog article which tells about each of them in detail, and you can go through the steps there. Just a few tips on this. Important to understand, if you're wondering whether you really need TLS, just think about this. If you're connecting through the TCP native protocol or through the HTTP interface, your credentials are passed in the clear. There's no extra step that ClickHouse takes to encrypt these things. So you need to enable TLS to protect those credentials. So even on internal systems, if you think that anybody can sniff the network, you should have TLS enabled. That's a really important point. So in general, I even run TLS on my laptop, so it's really not very hard to set up. The second thing is that if you're using a non-public CA, you have to be aware that the steps to get that certificate accepted are going to differ for different applications. They're even different between versions of Ubuntu, for example. This is just an example of what you have to do to get Node applications to accept your new, your custom root certificate. Another thing about custom root, sort of in-house custom authorities, is you just have to have good hygiene. What I usually do is on my laptop, as I go set it up using scripts, and then I forget where I put it, and so I lose the keys. And then from time to time, I have to redo it. You don't want to be like that. You need to, and there's a number of products out there that help you maintain CAs. You want to be organized. And then finally, a really useful command is if you're setting ports, you want to be really sure that you have enabled and disabled the right things. So this netstat command is a quick way to find out that the ports are open and listening that you expect. So in this case, these are encrypted ports, and don't include the ports that are unencrypted. So this is what I would expect to see. So moving to clusters, very briefly, it's not too much harder. So we'll want to include the cluster traffic. There's a couple different ways that cluster nodes talk to each other. One is distributed tables. We'll make calls just as if a distributed query or a query on a distributed table arrives on logos 1, it will want to probably call out to another replica to get data. So that's going to go through port 9440, and then the inner server port that's used for replication between nodes or between replicas uses port 910. So setting that up is fairly straightforward. One thing that we recommend doing if you're using older versions of ClickHouse is go ahead and create an internal user. And I just call this user internal. And what I do is I'm going to restrict it to only the hosts where my cluster is running. So this will mean that I can use it. I can put this into the configuration files, and in fact, it allows us to do the following: to set up the first of all the inner server communication, so I can use this user internal, and I don't have to leave a password in the file because the network filter is going to prevent it from being used outside of the network. Of course, if somebody gets onto the host, they can use it as well. So this right here is turning off this is the inner server replication, turning off 9009 and turning on 910 or 9010. And then the other thing we want to do is set the TLS connections for distributed queries. So again, you see this example right here. This defines this remote servers.xml is the file that usually defines this. And so we see the host for a replica, we see the port to use to call, we see that, hey, we want to use secure communications, and here's the user we want to use. So this is the current way to do it if you're using a stable release of ClickHouse 2010 or below. What's coming in future, if you want to look forward a little bit, is as of releases after 2010, I can't remember whether it's 2010 or 2011, you will now have what's called a shared secret, which you can just write here, and this is actually used for communication specifically between the clusters, and will and as long as those secrets match, it will now connect across the network. And the cool thing about that is that one of the things that's tied to this is you no longer have to define a specific user, because what it will do is ClickHouse will now try and use the same user as initiated the query on all the nodes where they run subqueries. So this is going to be the recommended way to set this up going forward. So that's the connectivity between both for a single host as well as for a cluster. Let's look at encryption at rest. And there's really two options to do this. So the first one is if you're really concerned about the protecting data, the simplest thing is just to go ahead and encrypt the entire file system where ClickHouse data is located. So there's three options that you can use. Actually, there's many more, but here are three that that you may want to consider. The first is just to get Linux to do it using Linux Unified Key Setup. That's the standard encryption for Linux operating system, and you can encrypt partitions on the file system or encrypt volumes. So that's purely local. If you're in the cloud, Amazon in particular has default encryption or sort of automatic encryption on EBS volumes. So these are stored out in the network. You can enable that. It's just a switch. We've tested it, and at least for GP2 storage, there does not seem to be any performance overhead whatsoever, which is also Amazon's claim. That appears to be true. And then if you're on Kubernetes, again, the Amazon EBS provider has this as an encrypted option. And if you set that, your volumes will automatically be encrypted. You can do more complex setups than this, but these are things that are pretty standard just to make sure that your data is properly protected. Now, what you may also want to do is actually encrypt specific things in the database, because file-based encryption doesn't, if somebody can get into the database, they can see the data and select it, and it's now exposed. Starting with 2011, you can now use AES encryption functions. So these are done on a very similar to the MySQL AES functions. And in fact, one of the things we did was we have versions of these that are tested to ensure that they're exactly compliant with MySQL encryption, because a lot of people actually share data between MySQL and ClickHouse. So this is the basic form of the calls, and here's examples of how they're used. So for example, we're using with to define our key. With is an example of a common table expression if you have not seen that, and then we can use this this key to go ahead and encrypt hello world, so we get a nice encrypted value. We can go ahead and unhex that and decrypt it using the same key, and we get it back. So this is actually pretty simple to do. The one thing that you'll probably notice here is that you have to manage the keys. ClickHouse, there's no magic here. There's no server-side key management. That's something we're planning to do in future, but it's up to you to make sure that this is really that the keys are properly handled, and that you take care of rotating them and things like that. One other thing that's really important is you don't want to apply this willy-nilly, because there is expense required to encrypt values. It's going to take CPU time, and there's expense, of course, required to decrypt them. Since ClickHouse tends to focus on reads, this is actually going to change the performance of your queries. In the current implementation of OpenSSL, it's a little bit pokey. ClickHouse is going to be moving to boring SSL, which is quite a bit faster. So we do expect a significant speed up on this in the future. Another issue that this brings up from the, particularly when we're looking at the Aes encryption functions, is how to protect from sensitive data being leaked out of the system through logs. So if you go and issue those calls and then go look at your log, if you have it set to debug level, you're going to see a message pretty much like what's showing on this slide. And you'll notice a couple things. First of all, looks like the this thing got changed a little bit. But if you look at the decrypt over on the left side at the bottom, you'll see that the arguments have disappeared. So it's like, hey, sensitive arguments just disappeared. On the other hand, we can see that we've actually got this key shown in the in the text, so somebody could get into the log and they could see what your key value is. So there's two questions. One is, how did those sensitive arguments disappear? And the second thing was, well, how can I get rid of the remaining one? And the answer to that is to use what are called query masking rules. And what this slide here shows you, these are defined in config.xml, and they're basically regular expressions that allow you to find and substitute items that appear in the log. And it doesn't include, it's not only the text log, but it's also things like the query log table. So it basically prevents them from showing up anywhere. So in this particular case, this is the regular expression rule that looks for encrypt and decrypt function calls, and basically removes all the arguments and turns them into question marks. So the answer to the first question, or the first question about how did those arguments disappear, is, well, this rule is here by default, so they get taken out. And the answer to the second question, how would I get rid of that rule that was shown in the common, or that key that was shown in the common table expression? You would basically just put another rule in and you could make it disappear. So that's a great way to prevent data leakage. And just a few final tips before we move off security. There are many ways that many ways that hosts need to be protected. I'll just mention a few which are important for ClickHouse specifically. So ClickHouse does run as a ClickHouse user. That's actually good news. So you don't really have to worry about it running as root and running amok. At least we hope you don't have to worry about that. Two key things you want to think about are protecting the directories that contain data and credentials. So those are listed here. They're sort of the ones that you would expect. And it is important not to forget your logs, because those are also quite sensitive or potentially contain very sensitive information. And then the second thing is you want to protect the network around ClickHouse. ClickHouse can have well-defined users, can use network masks, but things like load balancers, firewalls, and then just making the servers unroutable to people who shouldn't see them anyway. These are things that you want to consider in your security regime to protect your data and to operate ClickHouse safely. So that's been kind of a lightning tour of sort of the ways that you can secure a ClickHouse server. What I'm going to do now is turn this over to Alexander Zaitsev, who's going to talk about building privacy-aware applications. So Alexander, take it away.
Thank you, Robert. Hi, everybody, and let's continue. Probably one of the most important questions that come from application design perspective, and especially for SaaS businesses, is how to build multi-tenant applications in ClickHouse. And there are different ways to do that, and those ways are distinguished by different isolation level. For example, you can have dedicated ClickHouse installation per tenant, and in this case, you only need to care about shared networks, if any. Or you may have a dedicated ClickHouse cluster per your tenant, and dedicated cluster inside the ClickHouse, inside the bigger ClickHouse cluster. And in this case, you share more resources like Zookeeper, you may share configuration files and network, and you need to make sure that the data between different tenants is properly isolated. You can go to even less isolation, just separating databases and have separated database per tenant. In this case, you you start to share ClickHouse hosts between tenants, and tenants share more and more resources on the same machine. Or you can go to dedicated tables and create separate tables per tenant, or you can even have the same table that is shared across multiple tenants. Those designs, they actually come from your application requirements. If you don't have too many tenants, the best way is to isolate as much as possible, probably on installation level. If you have thousands of tenants, you cannot afford even table level isolation. You have to use shared tables. And in this case, you need to be much more careful about how you isolate queries and data between your customers. Next slide, please. ClickHouse provides multiple ways how you can control access and restrict access to the private data, tenant-specific data. The old-fashioned way is using users XML, and this feature is almost non-documented. I don't know why, but you can specify the list of databases that the user is allowed to access. So in this example, the user demo can access only a database demo, and he or she cannot read any other databases at all. This is the golden standard if you use old ClickHouse versions. With the new ClickHouse versions, you actually have more flexibility. You can restrict a particular user to access the database or access a particular table in the database. So it's much more flexible and more powerful as well. Next slide. If you go to the shared table model, you need to make sure that users cannot see each other's data. You may control it on application level, providing certain proper filter, but it's better to control it on a server level. And ClickHouse provides support for that. You can configure so-called row level security filter. And again, there are two ways: old way and a new way. In old way, you would configure it in XML file, just specifying a separate filter condition, which is applied to where condition at the beginning stage of query processing. Or you can use the new Rbac-based approach, where you create a row policy filter and specify the same condition. This is great. One of the limitations here is that if you have many tenants, you will have to repeat the separation for every single tenant or single user. And one of possible improvements in this area is to do some templating. So you can specify that you can just take a user that accesses the database and applies it as a filter to all your tables. Let's go to the next slide then. Another popular application level task or configuration level task is how we can drop tenants. So if you build self-service, you might have some customers coming or some other customers signing off, unfortunately, and you need to make sure that you can delete the data properly. ClickHouse does support several ways to do that, and the most efficient way is to drop partitions. But in order to drop partition, you need to design a schema so so tenant is kind of limited in a partition scope. If you have database or table per tenant, this is very easy to drop. You just drop databases or tables. If you have partition per tenant, it's also easy to drop. And again, the question is, how many tenants do you have? If you have small number of tenants, you go with one design. If you have a bigger number of tenants, you go for another design. The worst case scenario is when you have to use a shared table for all your tenants. And in this case, in order to drop the tenant, you need to execute alter table delete statement. This is good, it works, but it might touch all your data. And consider if you have several terabytes of data or tens of terabytes, then when you execute alter table delete, then ClickHouse will have to touch virtually all your database, resort it, removing this tenant, and this is a huge I/O overload. What can be optimized here is first, if your data is also somehow partitioned, more or less, okay, then you can limit your alter table delete to a certain partition. This is a new feature which is available in 20.12. And we are working on lightweight deletes that will allow ClickHouse users to delete data in more or less synchronous way without much overhead. Next slide, please. Another important scenario is data retention requirements. So quite often we need to keep data for a certain amount of time, and depending on your schema design, you can implement different scenarios here. For example, we can define a TTL delete expression to keep the data for a single month and drop after that. This is very efficient for monthly partitioning. Or we can have a TTL expression that uses the date column and another column that we keep together with our data, which is called TTL days, which in this example is called TTL days to keep. And with such schema design, we can have a very flexible retention policy. We can have retention policy for every tenant separately. For some tenants, we may have data for 7 days. For other tenants, we may keep data for 30 days, and so on and so forth, depending on subscription plan, for example. And in order to be efficient, you need to partition data daily in this case. It's interesting that you can specify function calls in TTL delete statements. In particular, you can put dictionary call here, and that allows you to configure actual TTL in some external table, which is exposed as a dictionary, and modify it if necessary. It's worth mentioning that if you modify this TTL expression, it doesn't apply to the data which is already in the database, but it will apply to the new data that will come after that. ClickHouse also allows you to define arbitrary expression during TTL delete where. In this case, you can specify any SQL expression on your table columns. In addition to table level TTLs, you can specify column level TTLs. For example, you may have a table that keeps your some marketing data, for example, and you don't want to keep your customer ID for longer than 1 month, but everything else you may want to keep for 1 year, for example, if you have some models that require more data. And you can do it in ClickHouse, just defining the column level TTL expression like shown here on the slide. Next question, next slide, thanks. Another things that are important to consider, and those are kind of in between of application design and server configuration. First of all, as we mentioned earlier, there are some tables in ClickHouse that may expose sensitive data. And you need to make sure that this data is masked or those tables are not accessible to the users. There are at least 3 tables in question here: system query log, system text log, and system processes that may show the data. For example, if your user can run show processes statement, then he can see all queries that are running on the server potentially, and he may see the sensitive data in those queries. So those operations needs to be restricted. Another kind of practice is related to keys management. ClickHouse doesn't have good keys management yet. This is in design stage. And if you use Aes Encryption Functions, then in order to kind of forget the data, you can just lose the keys. And if there are no keys, then the data cannot be recovered at all. One more interesting ClickHouse capability is related to ClickHouse settings. As we discussed earlier, you can define different settings on user or profile level, but by default, user can change the settings using set command. In order to protect some settings from being changed, ClickHouse has so-called constraints on settings. So you can define that certain settings are read-only, or other settings cannot be changed above a certain limit, and so on and so forth. Those are good to keep in mind if you allow users to execute set operations. And non-read-only users usually can do that. And last but not least is secret management in general. Currently, it's application responsibility. And it's not just the management of secrets for encryption function and some server level things. It's actually more, for example, if you create a Kafka engine table in ClickHouse right now, or if you create MySQL engine table in ClickHouse, or if you create a dictionary that connects to some external source, you have your keys as a table definition. And those are exposed if somebody will run show create table statements, he will see the keys. This is definitely needs to be fixed, and we're working on that as we speak. So what next? Probably, Robert, you can wrap up.
Great. Thank you, Alexander. So we just want to summarize very quickly what we've touched on. So as we showed in this talk, ClickHouse security has advanced enormously over the course of 2020. That was, I've been working on ClickHouse for about 2 years, and when I started, it was XML files, and yeah, you could do TLS, but it was all pretty painful. The introduction of Rbac, LDAP, AES encryption give you some, now give you a really strong feature set to secure your data both in flight and at rest. Privacy is really a property of the applications. ClickHouse has a number of features that help you implement things like GDPR right to forget. And so but they have varying costs, and that's one of the things that you really do need to think about is how much is it going to cost you, for example, to delete data, and there's a trade-off between that cost versus how many tenants you want to support. And Alexander showed a number of options. In 2021, we're continuing to move forward on security. Two really interesting things that have already merged include boring SSL. So that's we're moving off OpenSSL as the default implementation for TLS using boring. One of the things that this does is it significantly boosts the performance of encryption in the AES functions and elsewhere. And LDAP role mapping is now just merged a couple days ago. And we have work in progress on Kerberos as well as lightweight update deletes that Alexander referred to. So with that, we're done. One of the things that here's a few references. For ClickHouse on GitHub, as well as the Altinity blog, we'll be publishing a bunch of stuff on security this year and context. And I would encourage you, if this is an interesting topic, please do give us a call if you have particular security concerns around ClickHouse. Obviously, if you're already a customer, that's a just log a support case. For those of you who are not, please feel free to call. We'd be delighted to talk about this topic. It's something, as you can see, that we're very interested in. So with that, I'm going to pop up this poll that I promised. It's very short, and I hope you won't mind taking a few seconds to answer it. And in the meantime, we'll open it up for questions. There were two that came up in chat that I'd just like to cover. One is a repeat. Which data protection standards are you referring to? GDPR is the main one, obviously, but there are other standards emerging in the network. There are, of course, in the United States, things like HIPAA, which has existed for a long time. There's PSS, it's the credit card protection standards. In fact, the log cleansing was actually implemented as a way of allowing people to store credit card information safely and not have it leak to logs. So there's a bunch of standards that are applicable here in these, you know, and it's not just GDPR. There's a question about which protocols are supported. For TLS, do you have 1.3, 1.2? Yes, both are supported. What is specifically not supported is SSL v2 and SSL2 and SSL3 are not supported. Those are specifically turned off. You can enable them, but they're no longer considered secure. So ClickHouse has them turned off by default. And we have some questions coming up here, Alexander. Here's one for you. How do the traditional file-based approach and the Rbac SQL-based configuration of users play together? Are all Rbac features available in user configuration files?
No, not all Rbac features are available in user configuration files. Rbac features are actually much more powerful. In user configuration files, you can only control access to databases and row-level security, and that's it. On Rbac, you have roles which are missing. You have also ability to control access on table level, on column level. We didn't show it in examples, but you can also limit columns that user can access to, and also manage access to other ClickHouse capabilities like system calls, set calls, and so on and so forth.
Yeah, another interesting thing is these commands also support the on cluster keywords, so you can blast these out across a cluster. So no more, you know, like SSHing into. Well, of course, none of you guys did that. That's only me. You're probably using Terraform or something, but you can get that stuff blasted out pretty well. So great question. Here's another one for you, Alexander. Does the multi-tenancy model impact ClickHouse insert performance? Is shared tables the fastest approach?
Hi, Andrei. Actually, it depends. It depends on how you insert the data and how many tenants do you have. As I mentioned earlier, if you have hundreds of thousands of tenants, then and if you collect data in a single log and insert in a single insert statement, it may result that in one batch of data you have many tenants, and if you partition data by tenant one way or another, it will generate too many small pieces of your data. That's small parts for ClickHouse. That will definitely affect your performance. That's why we typically recommend, if you have hundreds of thousands of tenants, go to a single table design, which is better from performance and operational perspective, but it has some security drawbacks.
Okay, here's a question. What's a ballpark percentage estimate for the security overhead on ClickHouse?
It depends on what security you apply, right? Again, it's a trade-off between being secure and being fast. If you use Aes Encryption function, this is a huge overhead on the data being encrypted. The TLS encryption for connections, this is absolutely transparent, and you will hardly notice that.
Yeah, and AES the boring SSL. Actually, there were some interesting numbers. Just speaking of this, one of the tests that Milovidov ran when he merged this, he was showing something like 30 times increase in performance for AES, but there's still no question that that is slow, and it's slow in your queries. So so you're definitely going to feel that. Other things, there's virtually no impact. Here's one. Is it possible to configure Kafka engine to use multi-tenancy models? For example, split messages from one Kafka topic to separate databases or tables?
Yeah, you can do it, but so you can split single topic to multiple destinations, because you typically attach materialized view to your Kafka engine, and in materialized view you can have a where condition, and depending on this where condition, that could be a tenant ID, you can route this data to a different table on the database. So yes, you can do it, no problem.
Yeah. An expansion on this. Yeah, about sort of distinguishing between different security settings. We don't have a comprehensive list. I think in general, security things like Rbac are really cheap. They're just not very expensive. Anything that involves encryption is more expensive. The biggest issue that we find people run into, and the reef that will undo you, is the cost of deleting things. And the reason here, let's just take the worst example. Let's say you have 1,000 tenants sprinkled, in a big table that's sprinkled across a big cluster. If you are not careful, deleting one tenant out of that will force you to touch every part in every version of that table on every cluster. It's a huge overhead. So and when you touch a part, you actually have to rewrite the part. That's how ClickHouse deletes data. And in fact, that's why we're so interested in this lightweight delete feature. So that's something where you need to be aware of that, and you need to design it into your application so it doesn't become a problem. Here's one. Is there a tutorial on how to set up certificates with Let's Encrypt and automate renewal with Certbot? Can't find anything on that. Alexander, I think the answer to that is I don't know of one. I mean, I've seen blog articles, but that's a great question. And if we can find something, we will post it.
Mm-hmm.
I wrote the blog article for ClickHouse network security, and I just said, you'll figure it out. But that's a good one. We will now go ahead and go back and look for that. Okay. I think that covers most of the questions. Let's see, we'll stay here for a minute more if there are any further questions, but otherwise, thank you very much. We really hope that this was useful, and look forward to talking to you more about security topics. As I said, we'll be continuing to talk about this on our blog and really share some of the interesting things that are going on with security on ClickHouse. If you have more specific questions, please feel free to check in with us at info@altinity.com. We'd be happy to discuss it further. So with that, Alexander, thank you very much. And thank you to everybody in the audience. We really appreciated having you here today.
Thank you. Goodbye.